Welcome to the solar system. Here we are in our solar system unit. We're just going to start this thing. Now, here's a great picture of our solar system, except for, of course, it's not to scale. So, we're going to be working on scale in our solar system. And so, the things that we're going to go through are how big is our solar system? Well, if we were traveling through space, it would look something like this inside of what we call a galaxy, which is a collection of stars. And there's lots of galaxies out there, but in our special galaxy, which we call the Milky Way galaxy, we are one of billions of stars. And if you find us, this little star, you're going to find our solar system. Sol means sun, basically, in a sense. That's the name of our star. And so our solar system is the system that's going around our sun. Due to gravity, we stay right there with our sun as we're traveling through space. We stay with our sun. We don't ever leave it because of gravity. And so in this system, we've got planets and asteroids and all sorts of cool stuff. But if you looked at it, scientists think our star isn't massive mega. It's kind of smaller on the smaller side, but it has a ton of gravity. And compared to us, it's massive. And so when we get into this solar system that we're in, we see our massive sun and we see all the cool stuff associated with it. This is a star right up close to us. And it's burning from inside out, exploding what we think is maybe a billion nuclear bombs a second, right there at the core. And it doesn't explode itself because it's so huge. The gravity holds itself together. So it's this massive fiery, furnace. It's exploding from the inside, but not exploding, staying close together, locked in because of gravity. Well, just a little further away, we start to get into our planets, starting with Mercury, then we get to Venus, then we get to Earth and Mars. Those are our smaller terrestrial planets, which are closer to the sun. As we get further back, we get into our giants, like Jupiter, Saturn, Uranus, Neptune. And then Pluto's way out there, and it's just a tiny little dwarf planet. It's not even bigger than our moon, so it's actually smaller than the moon. We'll talk more about Earth, because this is Earth and space science. We know a lot about Earth because we live on the planet, so we have a chance to research it. But we're finding out more stuff about Mars. We have great imagery of Mars. We know a lot about the surface of Mars due to our satellites. We know some about the surface of Mars due to our rovers, the surface of Mars. Deep within these canyons, we got some pretty cool stuff. Huge storms on Mars. Jupiter's right here. In fact, there's a red spot of Jupiter. That's a giant area around Jupiter. That's a huge storm that's been going on for hundreds of years. And then we've got also moons around Jupiter. Moons that are the size of Earth. They're huge. So Earth would be a moon around Jupiter. Jupiter's pretty big. Saturn's got those beautiful rings and great, gorgeous, glistening rings of ice. And you can see them. It's not super thick. We've also got Uranus and Neptune. Pretty epic. I don't know if you can hear the music as well as I can, but it's epic right now because our solar system is epic. Well, we're going to move forward. You already know that we live on Earth. At least I hope you know that. If you don't, then we live on Earth. Yes, this is true. And Earth, being a terrestrial planet, is close up, has life on it. We live right here in our neighborhood. So if you were to look, we're right about here. Now, this is not to scale in any way. All of these planets are not the right distances. In fact, distance is really hard to do with planets because if we were to show the distances, all you would see is these tiny little specks of dust, and that's about it. So we can't do distances. We have to keep it just the way it is in order for them to be able to look and see the planets. But this is pretty close to the size of our planets when looking closer to each other, a little off on scale. But here's a good scale model of our Earth and the Moon. You've seen this one before. There's Earth on the left, Moon on the right. 30 Earths can fit right between the Earth and the Moon. The Moon is about a fourth the size, not real big. And there it is, out in space. Here it is with all the planets between Earth and the moon. They actually would fit side by side. That's how spread out the moon is truly from Earth. Here's North America right up against Jupiter, something we've never seen really before. There's the giant spot that's about the size of Earth. That's a huge storm on Jupiter that's distinguishable. Here's our Earth stacked side by side to be about 6 Earths side by side for the size of these rings around Saturn. Here's what the rings of Saturn would actually look like if they were on Earth. Here's what it would look like from Ecuador, which is right by the equator. It would just be this thin line, which would be really kind of cool and sci-fi. If you went a little bit outside of that, like up to Polynesia, Polynesian Islands, you'd start to see them like this. If you went, let's say, Washington, D.C., you would see the rings like this, which would be pretty cool looking. If you went from Alaska up on the tip, you'd just see the tops of those because of the curvature of the Earth. Here's a comet. In fact, the comet's pretty cool because we just landed on one of these bad boys and kind of poked around and saw what was going on there. Here's about the size of a comet compared to downtown LA. People always wonder, is comets huge? Yeah, they're pretty good size, man. Not gonna lie, comets would mess us up if they hit Earth. Now, us compared to the sun, that's the biggest comparison. The sun is massive, and here we are down here, third planet. Oh my goodness. We're actually just a little bit bigger than Venus, but Venus is considered our sister planet. Mars is smaller, Mercury's tiny, Jupiter's bigger, but here we are compared to the sun. Massive. It's kind of terrifying, right? How small we really are. I mean, if we were stuck up against the sun, here we'd be, and the actual ejections, the mass ejections and things would be killing us. Here is the sun, though, from Mars, which is kind of interesting. It looks smaller because you're further away. Here's our Earth if we were on the moon, standing there looking at it. Beautiful looking object. Here it is from Mars, just a tiny little spot in the sky. Here it is from Saturn, way the heck out there. It looks like a star, but it would be our Earth. This is pretty cool. If you were to have all the planets side by side, well, what would they look like? Well, there's the moon. We've seen that one a bazillion times. There's Mercury. No, that's Mars. Sorry. That's Mars. Venus. Neptune. Well, wouldn't that be cool looking? Uranus. Jupiter. Saturn. Boy, that would be super cool if you could see that outside your window. So there's just a quick little tour. That's what we went over in class today. And then we also got our booklets. So hopefully you've got your booklet with you and you received one. If you have not received a booklet or you have no idea what I'm talking about, all you'll have to do is head on into your class. I'm going to show you first period as an example. And under classwork for week 11, we've got our agenda right here, which has everything on it, including this video. And then we've also got your solar system booklet for the week right here. And that's going to take us through, and we're going to learn a little bit about scale as we get into our project next week. Hope this works out for you. We'll see you again.